Hi, in this video, we'll talk about ArrayList in Java. So this is a class in Java. So we'll discuss in detail about ArrayList in Java. This is one of the classes in Collections framework. Okay. So the same diagram which we saw in our previous videos also. So at high level collection and inside under that, you have three interfaces. Inside the list, you have ArrayList. This is what we are going to talk about, right? This is ArrayList. This is a class. So we'll talk about this thing. So this is this implements list interface. Okay, child of list interface. So what is ArrayList? So ArrayList is a class which implements list interface. Right, this is child of list interface which implements. So the underlying data structure for ArrayList is resizable array or growable array. So in one of our previous videos, when you're talking about the difference between collections and arrays, so collection is implemented on top of some data structures. That is what discussed, right? So in that context, ArrayList is means the underlying data structure behind the ArrayList is resizable array or growable array. Okay. So duplicate elements are allowed. So this is what we discussed list interface, right? In the list interface also, we have seen what is the specialty of list is it will allow duplicate elements. So duplicate elements are allowed and insertion order is preserved. So which order you inserted the elements to the list and the same order they are inside the list. So that order is preserved. So heterogeneous objects are allowed. So we already discussed at the high level is what is the purpose of going with collections, right? One of the advantages is it will accept heterogeneous objects, means you can put multiple data type of elements inside a single collection. So you can add one integer, you can add one string, you can add one boolean, something like that. The mixed elements you can store inside the collection, means array list. So null insertion is possible. If you want to insert null value also, it will allow. So this is the brief information about ArrayList. It's a class which is which implements list interface. It is developed on top of this, means data structure is called resizable array or growable array. So duplicate elements are allowed, insertion order is preserved. It allows heterogeneous objects and null can be inserted into this ArrayList. Okay. So there are, as it is a class, it has multiple constructors. So one of the constructor is the simple one. ArrayList is a class, right? Class. So object reference new class means it is the basic, like basic constructor. ArrayList is equal to new ArrayList. Okay. So this is how you will initialize an ArrayList. It will create the moment when you write something like this, what it will do when you're programming. So it will create an empty ArrayList object which default initial capacity is 10. Right? We are saying it will hold multiple values, right? So if it is holding multiple values means the moment when you create an array list like this, it will create an array, sorry, whatever it is. So 1, 2, 3, 4, 5, 6, 7, 8, 9 means. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So with this initial capacity 10, it will create something like this. Okay, but you will not have any elements inside this, all are empty. So empty ArrayList object with the default initial capacity 10. So this is how it will create. If ArrayList reaches its max capacity, then a new ArrayList object will be created with a new capacity by following formula. Right. So what happened? I created one ArrayList something like this, and I keep adding the elements. So we have add method, right? With the help of add method, I'm adding. So I added 10 elements, but now I need to add 11th element. Okay, I need to add 11th element. Then the behavior will be how it is. So if it is a list, this is the L object, it will reference to this one. So if you need more than 10 elements, so what it will do, the moment when you try to insert 11th element, so it will create another array with more capacity. Okay, with more capacity. What is that capacity? For that there is a formula that we'll see. Okay, so it will create another one. So it will remove the reference to this, and it will give the reference to this object. So then it can be destroyed with the help of garbage collector. Okay. So whenever garbage collector sees this object, if it is not used by any other, I mean, if you do not have any reference to this, it will destroy the garbage collector, this object. But what is the difficulty here? So the moment when you create more than the capacity, then it will create another array list, and it will keep copy all the elements into this 10 elements, then 11th will add. If the moment it reaches the end, then again it will create another big array, and it will copy all the elements from here, and it will add the which element you want, and the reference will be removed here and given the reference to this one, and it is garbage collector will destroy this object. This is a expensive task, right? So because of that, performance is decreased when you compare to arrays. That is what we discussed in one of our previous videos, this differences between arrays and collection. So collections are, if you concern about memory, you need to go with collections, but performance will be decreased. If you go with arrays, you need to know the size of the array in advance. So that is lacking in the memory level, but performance wise it is fast. Okay, so performance wise it is fast. So this is how it will internally work. So what is that formula? Means how the new capacity will work. So this is the formula. New capacity is, so the new capacity is current capacity into 3/2 plus 1. So the moment when you reaches 10, if you try to 11, so what is that? 10 current capacity into 3/2, right, plus 1, means 2 5 is 5 3 15 plus 1. So this is with the 16 elements. At the moment when it reaches next one, so then 16 into 3/2 plus 1, to 8 8 3 24 plus 1, 25. This size is 25, right? If it is 25 into 3/2 plus 1, right? But there is no exact we cannot do 12.5. So but this is integer, right? So it will take 12 into 3, 36 plus 1, so 37 elements. If it is reaches, it will create another array list with 37 capacity. Okay, this is how it will create, but each time it will copy all the elements into the new one. So that is expensive, and because of that performance will be very low. Okay, this is one of the constructors. Array list L is equal new array list. So here another one. So array list L is equal new array list of int initial capacity. So if you know the capacity in advance, so how it is very similar to array. If you know the capacity of array, very simple. I'm going to store 100 elements. If you initially say 100 elements, then the moment it creates, it will create with 100 capacity. Otherwise, whatever we saw here, right? First 10, then 25, then 36, then 10, 16, 25, 37, something like that. It keep increase that. It needs to copy all the times. So performance will be decreased. So because of that, if you try like this, if you're going to add 100 elements, so create with 100, then while creating itself, it will be with 100 capacity. Then there is no need to create another one and copy all these things. This can be avoided. That is the advantage with this constructor. Okay, it will create an empty array list object with specified initial capacity. That is what we are discussing it. Empty array list with capacity 100. If you mention whatever it is an efficient way if you know the capacity. Also, if you already know and if you mention that one, that is what performance will be increased, right? So that is what we are discussing here. Okay, this is another constructor. So you have one more constructor. So array list L is equal new array list of, it will accept collection. Another collection you can give as it creates equivalent array list object for specified collection object. Okay, the similar whatever collection you give with similar, it will create array list. If you give another collection, which are there are so many collections in that diagram, right? If you give another one, it will convert into the array list, similar array list. This constructor will be helpful for interconversion between collection objects. That is what, if it is you provide another collection, that will be converted to the array list. That is the advantage when you go with this constructor. Okay, So these are all the three constructors available in ArrayList. So according to your requirement, you can use any one of these constructors. Okay. So all the methods present in the ArrayList are non-synchronized. So all the methods present in the ArrayList are called non-synchronized. So multiple threads can allow to perform operations on ArrayList. So if it is non-synchronized, so multiple threads can access this ArrayList. So relatively performance is high because threads are not required to wait. So if it is synchronized, so until one thread completes, another thread cannot access this one. So there it will take more time to finish the activity. But multiple threads means at a time, multiple threads can try to access this one. So because of that, threads are not required to wait. So relatively performance is high. So collections.synchronizedList can be used to get the synchronized version of ArrayList. So all the methods are non-synchronized. So it is non-synchronized class. So if you want to convert this non-synchronized class to synchronized version, then we already discussed in one of our previous video that this is utility class. Right, utility class. So with the help of this utility class, this is the static method available inside the utility class called synchronized list. With the help of this method, you can convert your non-synchronized array list to synchronized version of array list. Right. So if you see that diagrammatic way, so here I created array list is equal to new array list, and a list is equal to collections dot synchronized array list, and you need to pass this array list object here. So then what happens with the help of this non-synchronized array list, it will create synchronized list. Okay, and this list is parent of this. Obviously, it can hold that information. So if you see that this is non-synchronized version, this list is synchronized version. Right, with the help of collections utility class, one of the methods available in that is synchronized list. We can convert this non-synchronized version to synchronized version of this list. Okay. So a few more points about ArrayList is ArrayList is defined in java.util package. Okay, this is available in java.util package. If you want to use ArrayList, you need to import java.util in your program. ArrayList is best suitable for retrieval operation. Okay, so you have n number of elements inside this, right? But with the help of index, you can directly get that, whether it is in 1000 location also, if it is in 0th index, 1000th location index or 0th index, you just mention get of 1 lakh, right? It will directly get the value from there. If you mention get of 0 also, same time. So best suitable for retrieval operation, if you want to retrieve some information from. But this is not the best suit for frequent insertion or deletion operation in the middle of array, as it requires multiple shift operations internally. So what happens? Let's assume you have something like one array list, 1, 2, 3, 7, 8, 9, something like that. So with here, if you try to add one element in between, 1, 2, 3, 4 means third index. So what happens here? It will create, but these things will be shifted one by one. Right? It has to go to 4th index, it is 5th index, 6th index. If you try to insert one more, it has to go to 5th index, it's 6th index, 7th index. It has to shift right. Right. So that operation is costly. Means here only 3 elements. If you have 1 lakh elements, and if you are trying to add in the second index, so if you try to add in the second index, you have remaining 99,998 positions. It has to shift. If you do that operation more than one time, so every time you need to do this operation. So this is not best suit for frequent insertion or deletion. If you try to remove this element, so obviously it will come to this one, left shift. This is right, you need to do left shift. So the same thing, right? If you add, it will move to right side. If you delete, it will come to the left side. So but operation is same. So if you have so many elements, it will take so much of time, right? So this is not the best suit if your requirement is insertion or deletion. But if your requirement is only getting the data, then you can go for this. best suit for retrieval, not best suit for insertion or deletion operation in middle. Okay. So what could be the possible interview questions from the array list? So what is array list in Java? What are the different constructors available in array list? So whatever we discussed, we can explain that. Okay. So in our here we just saw only the theory of array list. In our next video, we will, with the help of all the methods in the list interface, collection interface, right? So if you go to the top, the diagram, right? In here, so you have few methods in the collections interface. You have something in the list. So you will get everything from here and here, right? So how you can use all the methods available in list, how you use in this class, and how you perform operations on a list, how you to create a list, how to perform all the operations with the help of those methods, we will see in our next video. Okay, so that's all in this video. Thank you.